Hello guys, I want to show you how to find the moment generating function for normal distribution. If you know the moment generating function, you can find it by finding the expected value ETX. And the PDF of the normal equation is written as 1 over 2 pi sigma exponential of negative half sigma squared x minus u squared. So you can introduce this ETX in this equation here. So we will get the integrate from negative infinity to infinity 1 over root 2 pi sigma, then e power tx, then e power negative half sigma squared x minus u squared. This is a constant. You can move it outside here, so it will be 1 over root 2 pi sigma integrate from negative infinity to infinity. Then we'll be left with exponential e tx and exponential e power negative half sigma squared, then x minus u squared. So the bases here are equal, so you can add the powers. So we'll be left with negative half sigma squared x minus u squared plus tx. So after doing that, you can now you can work out this. You are going to get x squared minus 2 xu plus u squared. Then there is a negative half sigma squared, then plus tx. Then you can find the LCM of this is 2 sigma squared. So you can divide here with this and multiply with it here. So this divided by this is 1. So you'll be left with x squared minus 2xu plus u squared plus tx. Then this one there is a minus here. So after this will be this divided by this multiplying by this, so it will be multiplying by 2 sigma squared. It will be multiplying by 2 sigma squared. Now you can remove this outside there. So it will be left with negative x squared minus 2xu plus 2 sigma squared tx divided by 2 sigma squared. Then we'll move this one outside, so it will be plus u squared over 2 sigma squared, because they are under the same base. This one. So after that now you can factor out 2x here in this equation. You can factor out 2x, so it will be 2x will be left with u plus sigma squared t. Yeah, will be left with 2x u plus sigma squared t. and then there is a x squared, then a minus, and then this will be divided by 2 sigma squared, then minus. This one will be a minus because of this negative here, so it will be negative u squared plus 2 sigma squared. So from there you will use completing square method to work out this. You can see this one, it is in form of x squared plus dx plus c. In this equation here we don't have c, so we have x squared and bx. So you can say x squared minus 2x u plus sigma squared t. Then you can add 2 u plus sigma squared t and divide it by 2 because this one is b. B now will be 2 u plus sigma squared t divided by 2 without the x here, because when you say x squared plus bx plus b divided by 2 squared, this x will not be included here, so it will be 2 u plus sigma squared t divided by 2. Then we are going to square it. Now is equals to, you want to this other side, you want it again, and you square it. So it will be 2 u plus sigma squared t divided by 2, and then you square it. So this 2 will cancel here, this 2 will cancel. Then in completing square method, I'm going to take this to x squared minus u plus sigma squared t squared. Bring this one this side, it will be minus u plus sigma squared t and squared. So I'm going to get this. So when we get this, now we are going to replace it to this equation here. This equation here, this one. I'm going to replace it here. So when we replace it here, I'm going to get negative x squared minus u plus sigma squared t, this one squared minus this one was a minus, so when it will come this end, it will become a plus. Still be plus u plus sigma squared t. Then here we'll put this, then minus u squared over minus u mu squared over 2 sigma squared. And even this, it was divided by 2 sigma squared, and there was a minus here. So it was divided by 2 sigma squared, and there was a negative here. So from there I'm going to work out this part with the square. I'm going to work out this. There will be u squared plus 2u sigma squared t, this times 2, then plus sigma squared t squared divided by 2 sigma squared. This, I'm going to open this. There will be u squared plus 2 mu sigma squared t plus sigma squared t, you square it, divided by 2 sigma squared, then minus u squared over 2 sigma squared. So from there we are going to divide this one divided by this divided by this, and this divided by this. There will be u squared over 2 sigma squared plus 2u sigma squared t over 2 sigma squared plus sigma squared t squared divided by 2 sigma squared minus u squared over 2 sigma squared. This one will cancel this, then this one will cancel this will cancel this, and be left with ut plus this will cancel 1 there, so we left with the sigma squared t squared divided by 2. We'll be left with ut plus half sigma squared t squared. Now from there you are going to take this our equation here. I'm going to take this our equation here. I'm going to replace it with this one, so it will be minus this one, 1 over 2 sigma squared x squared minus u plus sigma squared t now plus this one. Tumefanya hii hapa, tumefanya yote hapa, tukapata inabaki hii, so iongeze hapo plus ut plus half sigma squared t squared. Now it will be like that. So I'm going to replace it to our equation, to our original equation there. So it will be integrate from negative infinity to infinity 1 over root 2 pi sigma e power negative half x squared minus u plus sigma squared t plus ut plus half sigma squared t squared dx. Now we are going to realize that this will be equal to 1. Now we will be left with exponential of this. So MGF for normal distribution will be exponential of ut plus half sigma squared t squared. We'll be left with this. Now in finding the mean, I'm going to find the first derivative of this, and it will be differentiate this with respect to t. I'm going to get u plus differentiate this. When you differentiate this, I'm going to get half sigma squared 2t 2t. These two will cancel this, so I'm going to be left with sigma squared t. Then there is the exponential of ut plus half sigma squared t squared. Then we replace t with 0. So when we put 0 here, 0 here, 0 here, this one will be u plus 0 exponential of 0. And you know exponential of 0 is 1. So I'm going to be left with u. So this is the mean. And then finding variance. Finding variance, I'm going to find the second derivative of the MGF. And then second derivative will be differentiating this u plus sigma squared t exponential of ut plus half sigma squared t squared. I'm going to differentiate this, and I'm going to use product rule. Product rule. Now I'm going to differentiate this. Product rule. The derivative of this, you hold this constant, then you hold this constant, and you differentiate this. So let's differentiate this with respect to t. I'm going to get sigma squared, then multiply by g. You hold this constant, so it will be ut plus half sigma squared t squared, then plus you hold this u plus sigma squared t. You hold this, then differentiate this. When you differentiate this, I'm going to get differentiate this. You drop it here. I'm going to get u plus sigma squared t. Then I'm going to replace t with 0. When you replace t with 0, and be left with sigma squared, because this one will be exponential 0 plus this one will be 0, this one will be 0, so we will be left with u squared. So it will be sigma squared plus u squared. This is the second derivative of the MGF. So when finding the variance, we're supposed to take the second derivative, you subtract the first derivative, then you square this. So you're going to get this sigma squared plus u squared. You subtract mean squared, and we found mean being u. So I'm going to subtract u squared. So I'm going to cancel this. I'm going to be left with sigma squared. So variance will be sigma squared